Hello, welcome. Today we are here with a new question which is contains duplicate. Question name is contains duplicate. So let's go through the question. Let's see what exactly the question is given about. Let's try to do the brute force approach, and next we'll try to figure out the optimal approach too. So coming to the question is given an array of integers, given an array of numbers, basically array of numbers, return true. We need to return true. Okay, if the value appears at least twice, if the value appears at least twice in the array. Okay, and return false if every element is a distinct element. Every element is a distinct element. Okay, so what they are saying is they'll give you an array. They'll give you an array. If this array contains duplicates, like if it has a duplicate values, if it has a duplicate values, okay, if it has a duplicate values, simply say okay, true. Simply say true, which means it contains the duplicate values. If that doesn't contain the duplicate values, simply say false, which means this array, whatever the array is, 2, 1, 3. So from this array, if it contains duplicates, return true. If not, return false. That's all. Pretty straightforward and simple question, guys. So just to note down, question number is 217. Question name is contains duplicate, and this is of a easy level question. So yes. So coming back to the point, so this is what the question is. They'll give us an array of numbers. We need to return true or false based on the condition. What is the condition? If it contains the duplicate values, okay, return true. If not, return false. Okay, I hope this question is clear. Now let's jump into the next one. Let's jump into the examples. So what is the first example, guys? First example is 1, 2, 3, 1. So what will be the answer that will return? Answer will be true, correct. Why we are returning true? Because there are duplicates. There are duplicates here, right? What are the duplicate values here in this array, guys? Duplicate values are, if you observe, index 0 has 1, index 3 also has 1, index 0 has 1, and also index 3 has a 1. This is index 0, this is index 1. Both the indexes have 1, so it contains duplicates, so returning true. Okay, now second one, this example, guys, example 2. Now what will be the answer, guys? Obviously this will be false, right? This will be false. Why false? Because all the elements are distinct elements. Distinct elements. What does this distinct mean? Distinct elements are nothing but unique values. So that doesn't have like repeated of values. That doesn't have a repeated values. That doesn't have a repeated values. All the values are distinct, unique values. All the elements are unique values. Okay, so this example, it is true because it has duplicates. In second example, this is false because it doesn't have a duplicates. It all has the unique values. Okay, good. Now let's go to one more example. So in this example, guys, what will be the answer? Obviously, answer is true. Why? Because there are multiple duplicates. If you take 1, we have at index 1 and also index 2. If you take 3, we have this at index 4 and also at index 6. Vice versa. Even 4 is being repeated, 2 is being repeated. It doesn't matter how many elements have been repeated. It only matters whether it contains duplicates or not. So here itself, we can say, okay, these elements are itself a duplicate. So we will return true. Will return true. I hope this question is clear. So let's jump into approaches, guys. So what will be the first approach that you think of? What will be the first approach that you're thinking? So let me take an array. Let me take an array, guys. Let me take an array first. Array equals to, let's take 1. Okay, let's take 1, 3, 2, 1, 8, 9, 7, see, 2 again. So now what will be the answer for this question, guys? What will be the answer for this example, guys? Say me, come on. What will be the answer? Correct. Answer will be false or true? Answer will be true. Answer will be true, guys. Why answer is true? Why answer is true? Anyone think? So answer is true. Why? Because this in element 2 is being repeated at two places, which means this array contains duplicates. This array contains duplicate values, which means answer will be true. Okay, we know the answer. Now let's jump. How we can solve this question? How we can solve this question? So first approach will be obviously think of the brute force approach. Think of the brute force approach. Okay, what will be the brute force approach, guys? Think. What will be the brute force approach, guys? What will be the brute force approach? So just think, just give it a try. Okay. So brute force approach will be like this. Like as we know, brute force is nothing but the straightforward, simple example. What is the main thing? What is the main aim here in this particular example? What is the main aim we need to find? If the element, if we take any element from the array, if this appears more than once, if it appears more than once, that means this contains duplicates. This contains duplicates. So how you can check that whether it has more than one time or not? So what we'll do, let's take one. Let's take one. I'll compare with all the indexes. Index 1, index 2, index 3, index 4, index 5, and index 6. Do I find one here anywhere in between? No, obviously no. I didn't find one. So this element is only unique. This element is a unique element. I'll take 3. I'll do the same check. I'll compare with first element after 3, second element after 3, third element, fourth element, fifth element. Do I find 3 anywhere? No, I didn't find 3. Now what I can say, this 3 is also a, this 3 is also a unique element. Okay, now I will take 2. Now I will take 2. I'll compare this 2 with 8. Are they same? No, this is not same. I'll compare with 9. Are they same? No. I'll compare with 7. Are they same? No. I'll compare with 2. Now are they same? Yes, they are same, which means this 2 is not a unique. This 2 is not a unique value. This 2 is not a unique value. So I can say, okay, 2 is repeating one time, at least one time. 2 is being repeating at least one time. So this array contains duplicates. This array contains what? This array contains duplicate values. This array contains duplicate values. So what will be the brute force approach, guys? Take every element from the array and compare with the remaining elements. Compare with the remaining elements. So that will be the brute force approach, guys. That will be the brute force approach. What is the brute force approach? Take each element, compare with the remaining elements in the array. Compare with the remaining elements in the array. Whenever you find the same element again, that means it contains duplicates and you need to return. What you need to return? We need to return true. We need to return true. We need to return true, guys. Okay. If even though after iterating of the entire array, okay, if we don't find the answer, what I can say, okay, all the elements are unique, which means we will return false. We will return false. Okay. Now let's try down the steps, guys. So what is the first step? Okay, go to each element. How you will go to each element? Basically, iterate on array. Okay. Now after going to each element, what we need to do? Take, okay, treat that element as current element. Okay, treat that element as current element. After treating that element as a current element, what we need to do, guys? What we need to do after treating that element as a current element? What we need to do? Compare with rest of the array. Compare with the rest of the array. Compare with the rest of the array. Rest of the array in the sense right side of the array. Right side of the array. Right side of the array. Okay. Treat that element as a current element and compare with the rest of the array. How you'll compare? How you'll compare? Basically, again, you will run a loop internally from current element to end of the list. end of the list. If in between, if we find the current element in the current element in the internal loop, what does it mean? It means the elements are duplicate. So the current element has the second occurrence or occurrence in the array. So when we are running the loop internally, so we'll treat it as a current element, and we will start comparing with the rest of the array. Which side of the array we need to compare? Only on the right side. Only on the right side. Why? You can ask me, sir, why? Why only on right side? Why can't we compare on the left side? Because when I was here, I already know I compared on the left side. I'm coming from the left side. I know I already checked the left side. So there is no point of checking on the left side. There is no point of checking on the left side. Okay, that's the only reason, guys. That's the only reason. So if we find the current element in the internal loop, what we need to do? Return true. Return true. Why we need to return true? Why we need to return true? Why we need to return true? We need to return true because we have the same element twice. We found the same element again. That's all the reason, guys. That's all the reason. We find the same element within the array again. That's all. Will return true. Suppose if we don't find the array, what we need to do? If we don't find the array, what we need to do? We need to simply return false. We need to simply return false. When we need to return this false, we need to return false. After iterating on the entire array. So even if we don't find this element again, like after comparing for all the elements, if we don't find this duplicates, then we need to return false. I hope this is clear, guys. So what will be the time complexity for this particular approach? What will be the time complexity, guys? What is this approach? Basically, what we are discussing, this is brute force approach. So what is the time complexity here? The time complexity is big O of n power 2. Why n power 2? Because n power 2, for every element we are again iterating on the rest of the element. So if I am at first element, I am again running a loop. Internally to compare with the rest of the array. So that is the reason. So if I am at element 1, I am again running loop on the remaining elements. Okay, which is like n into n in the worst case, n into n in the worst case, and in total it will be n square. So that is the reason this brute force takes n square times. And now coming back to the point, do we have any space complexity here? No, that will be big of only one. No space is used. So okay, that is clear, guys. So this is your time complexity, this is your space complexity, this is clear. Now, is there any possible way to reduce the time complexity, guys? Just think. Is there any possible way? Just give it a thought. Just think. Is there any better approach or anything? Pause this video for a second and think for this particular thing, guys. Okay. Okay. I hope you have thought of the better way. Anyways, if not, let's see that, guys. Array equals to 1, 3, 5, 6, 2, 1, 4, 9. Okay. Now, is this array what we need to return? Does this contain duplicates? Yes. This one and this one are same. So return true. Okay. We will return. What will return, guys? We will return simply true. Okay. Okay. That is good. Now, as I said, is there any better approach? Have you thought of the better approach? Just think about the data structures that we have. What are the data structures that we have? Think of them, guys. Which data structures? At the end of the day, what we need to find out here is it's not the occurrence. We need to find out whether it contains duplicates. Think of this word duplicates. Duplicates, guys, duplicates. So at the end of the day, this array contains duplicates or not. This array contains duplicates or not is the matter. Duplicates or not is the matter. So we need to find out that. Now think of any data structure. Think of the data structures that we have. What are the data structures that we have? We have arrays. We have arrays. Okay. What else we have? What else we have? We also have strings, stack, queues, stacks, queues, hash map, hash set, and also graph trees. Like these are the things that we have. Okay. Now, when you think of these things, guys, when you think of these things, is there any data structure? Is there any data structures in this entire list? Okay. Is there any data structure in this entire list which will allow us to store only unique values? Is there any data structures, guys? Is there any data structure? Yes, we have a data structure that is called as hash set. That is called as hash set. So hash set is nothing but it is a one-dimensional data structure, guys, where it stores only unique values. It stores only unique values. Okay, what values it will store? It will store only unique values. Okay. Now the simple way to do this is, guys, the simple way to do is store store all these elements into this data structure. Okay, into this data structure. So what happens when, let's say, this is my hash set. This is my hash hash set. This is my hash set. Now, when you think this is your hash set, let's insert one by one values. Let's insert one first. Okay, one has been inserted. Now, what is the next value? 3. 3 is also inserted. What is the next value? 5. 5 is also inserted. What is the next value? 6. 6 is also inserted. What is the next value? 2. 2 is also inserted. What is the next value? 1. 1. 1. Do we insert 1? Do we insert 1 again? No. Why we don't insert 1 again? Because that is already there. 1 is already there. As I said, it contains only unique elements. It contains only unique elements, which means it stores only any value only once. It stores any kind of value only once. So this is already stored. This is already there. Now let's take next value, 4. 4 is not there. We will store. What is the next one? 9. 9 is not there. Let's store. Now, what is the length of this array? What is the length of this array, guys? What is the length? 1, 2, 3, 4, 5, 6, 7, 8. 8 is the length. What will be the length of this hash set? Basically, the size of the hash set. 1, 2, 3, 4, 5, 6, 7. What is the size of the hash set, guys? 7. Now, are they same? Are they same? No. But we store the same elements into this, no? We have how we created this hash set, guys? From these elements only, from the array elements only. But why the size is different? Why the size is different? Because as we know, it contains only unique elements. Whenever we try to insert the second one, that doesn't allow to store. It will not store again. Okay, so that is the reason the size of this hash set is 7. Now, if you compare 8 and 7, they are not matching, which means what I can say, if they are not matching, what I can say is the array contains duplicates, which means I can return true. Simple. Is this clear, guys? Why I'm saying when they are not matching? Because these are the elements that I have seeded into. These are the elements that I have seeded into hash set. If the same elements are not there, if I see the same elements, count should also be same. If count is not same, what does it mean? It means there are some duplicate values that are going into this hash set. That's all, guys. That's all. Pretty simple and straightforward approach. So this will take time complexity of how much, guys? Time complexity of big O of n. Why only n? Because we are only iterating on this array. Okay, we are iterating only on this array. What will be the space complexity now? What will be the space complexity now? This will also be big O of. This will also be big O of. And this will also be big O of n. Okay, time complexity is n, space complexity is also n. If you think of our previous approach, time is n square, but our space is 1. Okay, now here by reducing the space, we have increased it, sorry, by reducing the time, we have increased the space complexity. So sometimes it happens like this. So this is the another way to solve this particular question. So insert all the values into a hash set and check both the sizes, 8 and 7. In this case, they are not same. So that is true, which means it contains duplicate. Else, false. Okay, I hope this is clear. This is clear. Now, other way, the same way, guys. Now the same way, but instead of inserting all the elements, what we will do is, okay, before I proceed further, let me just take an example, guys. I don't want to club those things. Okay, I'll take only small example. Now this is my array. Now, what is this? This is my array. Let's say we'll go with the same approach, guys. We'll go with the same approach of hash set. We'll use the same data structure called hash set. Hash set. Now, I am at index 0, element 1. I'll try to insert it. I'll insert. Okay. Now, let's take 4. I'll insert 4. I'll take 5. I'll insert 5. I'll insert 5. Now, what is the next element? I got 1. Now, if you observe, this 1 is already there in the hash set, which means this is a duplicate value, right? Why? From where we got this one? From the array only. Now, from where we got the other one? From the array only, which means before you insert this one, before you proceed further, what you can say here, okay, you will simply go and check in the hash set. You will simply go and check in the hash set whether this element is there or not, whether the current element is existing or not. If it is already there in the hash set, what does it mean? It means, okay, element is there, which means it is duplicate, which means return true. That's all. That's all right, guys. No need to check in the further of the array. So in some cases, what happens is, let's say, okay, let's take it from the example itself. If you observe here, if I insert all these elements into my hash set, what will happen? What will happen, guys? What will happen if I go with the second way? What happens? I'll take to this one, go to this one, I'll insert this one. I'll go to the next one, I'll try to insert, but it is already there. I'll go to the next one, it is also already there. I'll go to the next one, it is 3. Okay. I'll go to the next one. Again, this is 3. That is already there. I'll go to the next one, 4. I'll insert 4. What is the next one? 3. It is already there. 2. This is not there. I'll insert. Next 4, it's already there. 2, it's already there. Now, after iterating of complete array, we came to a conclusion after checking sizes. This is somewhere around, I guess, 10. This is 4. They are not matching, which means these are not, like, it contains this array contains duplicates, which means true. Okay. After completing of entire array. Now, if you take these kind of examples, what happens? If we go with the third approach, which we discussed just now, okay, this is my hash set. Again, same. This is my hash set. If you take this one, this first one, okay, let me change the color, guys. Okay, this will be the first one. I'll insert. I'll take the second one. I'll go to check in this array, in this hash set, sorry. Now, when I check in this hash set, what it will say me, okay, 1 is already there. 1 is already there, which means it is already came from the array itself from the 0th index. And now I'm trying to insert the first index where the value is same as 1. Now what I can conclude here, I can conclude that the elements are duplicates. The values are repeating. It contains duplicate values. Okay, array contains duplicate values. Now, if you observe all these elements, I haven't even checked. For the remaining elements, I haven't even checked, but I can conclude here itself. So, by using this third way, what is the advantage? It's not an advantage, guys. Like it is not kind of an advantage, but the like what it will help is it will help us to understand how exactly we can use the hash set. Okay. This third way, what it will do is it will reduce the time of comparing the rest of the array. So whenever we have the answer like this, it will return the answer. Okay. Instead of waiting till the last element, it will give us the answer after first element itself. This is your third way to solve. So this is the difference between your first, second, and third way, guys. I hope this is clear. Now let's jump into code. Okay. Okay, int I equal to 0. Okay, let's create a hash set, guys. I hope everyone knows this hash set. Int. Okay, hash set. Okay, equal to new hash set. Okay, this is the way to create a hash set. Now what I'll do, I'll iterate on iterate on array, iterate on the array. So how I'll iterate, int I equal for I equal to 0, I less than nums dot length I plus plus. What we need to do? What we need to do? Iterate on the array. After iterating, what I need to do? I will simply check before inserting the element. I'll check. Okay, I will check whether my hash set contains the current current element. So how to check that? If hash set dot contains, we have a method called dot contains. For this we need to pass nums of I. Okay, if it contains, what it will do, it will return true and will come inside the if block. So if it contains the element, what I need to say, if it contains element, return true. Why we are returning true? If it contains, because we already have one element which is our current element inside the hash set. Okay, which is a current element that is already there in the hash set, which means it is being repeating. That's all. Will return true. If it is not there, what I need to do? Okay, this is not there, but I need to add that element into array. Add of nums of I. If it is there, we will return true. If it is not there, we will add into hash set. Why we are doing this step, guys? Because if you don't add, how you can know that whether this element came or not? Okay, add element into hash set. Hash set. Why we are adding this, guys? Why we are doing this? Because if you are not adding the element into hash set, there is no point of doing this hash set dot contains. I hope this particular step is clear. Okay, now let's return okay, after doing the entire iterations, after checking the entire array, if you don't get the answer, what does it mean? It doesn't have a duplicate. It doesn't have a duplicate. That's all, guys. These are the very simple steps that we have. Okay, let's run this. I hope this is clear. Okay. Oh. I guess hash set of integer. It should be hash set of integer. Okay. Now let's run this. So basically, guys, in this place, what we will give is the type of data. So int is primitive data type, but here we need to give an object data type. So integer is a wrapper class for int. So we'll provide that. That's all. That's not a big deal. So yes, so we are iterating on the array. For every element, we are checking whether it is already there in the hash set. If it is already there, return true. If not, add the element. At the end of the array, what we will say, if the element is not there, okay. If it contains duplicates, obviously it will encounter here. After iterating the entire array, if we don't find anything, so you'll simply say, okay, it doesn't contain any duplicates. That's all, guys. That's all. I hope you understood the video. Thank you.